This video is an introduction to chapter 6. So we are going to be staying in graph theory, but we're going to look at a different type of problem in chapter 6. So in chapter 5, we were looking at street routing problems. So things like having the mailman go down every street twice to deliver mail without doing any extra streets. And now we're going to be looking at what we're going to call traveling salesperson problems. And even though we don't really have traveling salespeople anymore, we still have these types of problems. So some of the elements we'll see in this type of problem is the traveler. The traveler can be a person, a group, an object like a package, etc. And then we have the sites. So the sites are going to be the places or locations that a traveler must visit. Okay, and we're going to use N for number of sites. And so I kind of think of this as maybe going around town running errands. I start at my house, maybe I go to H-E-B, Target, Walmart, then go back home. So the locations or sites would be the stores that I'm visiting, and then my home would also be a site. Now we also have cost, and this is going to be the expense of traveling from one place to another, or one location to another. Now when we see cost, we do think money, so it could be money. It could also be time. How long does it take to go from location to location? Maybe we measure in distance. So there's some different options for cost. Now a solution to a traveling salesperson problem is going to be what we're going to call a trip that starts and ends at a site and visits all the other sites. There's my cat. Once and only once. Okay, so we want to go to each location or site only one time. The only exception to that might be, of course, where you start and end, which we could think of as maybe your house. So the optimal solution would be the trip with the least cost. Okay, so when we do graphs in graph theory, remember that graphs are not drawn to scale, so a longer edge doesn't mean a longer distance, and the positions of the vertices is completely irrelevant. The only relevant data are the numbers associated with each edge. For traveling salesperson problems where we have more than 6 sites, we usually use a chart instead of a graph because it's less confusing. All right, so some common examples of traveling salesperson problems would be school bus routes. We want to optimize the routes to be efficient with respect to time and distance. Circuit boards. So when they drill circuit boards, thousands of holes must be drilled in each board, so it needs to be optimized to minimize time and cost. And then I always think of this last example, running errands around town. So we want to optimize the time and distance of our errands. So we want to get everything done in the least amount of time and distance possible.